Okay, in this problem, we're going to do limiting reactions. So it works the same way as the stoich. You need to find the chemical reaction, balance it, add your information of your knowns on top of it, and then you just have two stoichs to do instead of one stoich. So this is 22 grams of ammonia with 35 grams of oxygen to produce water and nitrogen monoxide. Okay. So ammonia is NH3. Oxygen gas is O2, Brinkelhoff. And it's going to produce water, H2O, and nitrogen monoxide, so NO. Okay, so we need a balanced chemical equation. Okay, I have 2 oxygens, 3 hydrogens, 2 hydrogens. Oh, so I'm going to start with the 3-2 even odd rule. Least common multiple is 6. So now I have 6 hydrogens, 6 hydrogens. Okay, and over here I have 3. Oh, and now let me do my nitrogens, 2 nitrogens, 2 nitrogens. So now I have 3, 4, 5 oxygens, but I can only have it in half. So I'm going to say 5 halves oxygen, just like when we do other combustions. Okay. So what I have to do now is to multiply everything by 2 so that I don't have any fractions. And then I will double check. Okay, 4 nitrogens, 4 nitrogens, 12 hydrogens, 12 hydrogens, 10 oxygens, 6 plus 4, 10 hydrogens. All right, so now I have my balanced chemical equation. So what do I know? 22 grams of ammonia and 35 grams of oxygen. So it's no longer saying excess for the other guy, and that's why we have to do 2 stoichs. We have to do the stoich with 22, and we have to do a stoich with 35. Okay, and so we can pick either reactant that we want. I'm just going to pick hydrogen or water. So I'm going to say blank grams, same as what we've been doing before. Okay. So now I'm going to stoich 22 grams of NH3, and I'm going to stoich 35 grams of O2, 2 grams of oxygen. Okay, so the first thing is grams to moles. Okay, that's our molar mass. 14, 15, 16, 17, 17.04 grams in 1 mole of NH3. And then we have to convert to water, so we have to use molar mass. Our unknown goes on the bottom, our known goes on the top. Okay. There are 4 ammonias for every 6 waters. Okay. And then back to molar mass again. So again, you're going to get that normal thing. We're going from grams to grams. So molar mass, mole ratio, molar mass. Divide by molar mass to start, multiply by the other molar mass to end. Okay, so let's plug that into our calculator. 22 times 6 times 18.02 divided by 17.04. Since I didn't use parentheses, I'm going to divide again by 4. And I get 34.897. So 35 grams of H2O. Okay, so if we had 22 grams of ammonia and we had an excess of oxygen, we would get 35 grams. Now let's do it for the other way. Now we're going to start with oxygen. Still molar mass, 32.00 grams in 1 mole of O2. O2 goes on the bottom because that's what we started with our known. And we're still going to water, so moles of water on the top. We have 6 moles of water for every 5 moles of oxygen. And then molar mass. Notice this last step is exactly the same because we converted to moles of water in both. And now we need the molar mass to get to grams of water. So let's plug that in the calculator. 35 times 6 times 18.02. Divided by 32, and again divided by 5, 23.65, which would be 24 grams of H2O. So if we had 35 grams of oxygen gas and an excess of ammonia, we would get 24 grams. Now, what is the limiting reactant? That's the one that produced the least. So it's not water as your limiting reactant because that's the product, but it's the one that produced the least. So O2 is your limiting reactant. Okay? And that means this is your theoretical yield, because your theoretical yield is always whatever your limiting reactant gave you, because the reaction stopped at 24, so we couldn't make it to 35. So your theoretical yield is always the lower number. Your limiting reactant is always the one that limited or stopped the reaction early.